Good evening, Mr. Holmes. Today we're going to investigate Daphnia pulicaria, the water flea, and whether or not their tail is longer in the presence of fish or in their absence. Okay, first thing we want to do is we want to write a null hypothesis. Our null hypothesis is that mu1 minus mu2 would equal 0. And the circumstances, mu1 is the mean relative tail spine length in the presence of the fish, and mu2 is the mean relative spine length in the absence. Our null hypothesis, mu1 minus mu2 equals 0, would show that the tail length is not affected by the presence of fish, but our alternative hypothesis, mu1 minus mu2, would show that the presence of fish creates a longer average tail spine length in the water flea. And as per STEM, the conditions were met, and so we're going to write that down. And the test that we're going to perform is a 2-sample t-test for the difference in mean. Our sample data, N1 is 214, N2 is 152, X bar 1 is 37.26, X bar 2 is 30.67. The standard deviation for the first sample is 4.68. The standard deviation for the second sample is 4.19. This is our formula to find the t-statistic, where the parameters equal 0, and then we subtract the means and our sample means, and we square our standard deviations on the bottom divided by our sample sizes. We get that the t-statistic is 14.119, which has a p-value of 2.4 times 10 to the negative 36. That's by the calculator. But if we did not look for the p-value, it's known that a large t-statistic yields a small p-value. With that being said, we reject the null hypothesis since it's less than alpha, which would be 0.05. So in conclusion, at the 5% significance level, there's convincing evidence that the mean length of the Daphnia pulicaria, also known as the water flea, tail spines in the presence of fish, charamones, is longer than when the charamones are absent. The end. Hope you enjoyed.